Today, we are demonstrating integrations between HPE OneView, SUSE Manager, and SaltStack. This video will showcase SaltStack talking to OneView and SUSE Manager leveraging Salt to deploy a bare metal machine with Docker installed. SaltStack supports the notion of proxy minions, which are minions that control some device or service that would not normally run a minion. In this case, we have developed a proxy minion that communicates with HPE OneView version 3.0 and allows Salt to query and orchestrate resources provided by OneView. First, let's start the proxy minion and verify that it is talking to HPE OneView. Note that SUSE Manager recognizes the availability of the proxy and adds it to its inventory. We can execute Salt's test.ping command against the OneView proxy to make sure that OneView is responding. Salt's self-documentation functionality allows us to list the functions provided by the proxy's execution module. The list shows about 20 functions, including abilities such as listing enclosures, servers, profiles and profile templates, creating profiles, powering servers on and off, and so forth. Let's list the enclosures available to OneView. In this case, it's just the one. We can also get detailed information about enclosures, including hardware, onboard administrator IP addresses, interconnect modules, and so forth. The same details can be retrieved for servers in the enclosure. We can retrieve things like ILO IP addresses, as well as whether or not a profile has been applied to this particular machine. More concise information is also available. Let's list just the names of the servers in the enclosure. Salt employs a concept called grains. Grains represent information about a particular minion or device. The OneView 3.0 proxy minion exports details about OneView into grains. This is a list of all the grains known about this particular proxy minion. We can also retrieve individual grains and leverage Salt's powerful tools for targeting minions based on grains. This example shows us targeting the OneView enclosure based on its onboard administrator IP address. This would be quite valuable should there be multiple enclosures known to OneView, or even multiple OneView instances. Commands could be sent by Salt to exactly the enclosures or OneView instances that need to be addressed. Now we're going to retrieve all the available server profile templates so we can select one from which to create a profile and apply to a particular server. This server will receive all settings requested by the profile template, and then pixie boot and be provisioned by Cobbler and SUSE Manager. Here we are creating the profile. We will flip over to OneView's web interface to show the corresponding workflow in the GUI. Profile creation has started. In the OneView interface, you can see that server TC2 is having its profile created. Profile creation has completed, and Salt returns a dictionary with details about the server. Let's have a look at the server profile. From the OneView UI, we can see specific details about the server profile settings. For example, we can see that the boot order has been set. Take note that because the hard disk is blank, SUSE Manager will install an operating system and configure it according to its AutoYast profile via the Cobbler PixieBoot service. Let's turn on the server and monitor the automated installation of the client via SUSE Manager by observing the ILO console. Automated installation begins. During the first half of this installation, the server will download packages from repositories the server has access to, as defined in the AutoYast profile. Let's take a look at the AutoYast profile we defined within SUSE Manager. Within the profile, we can configure settings such as which software repositories the server will have access to, which software packages will be installed and running, hardware devices and software configuration settings, as well as pre- and post-installation scripts to fine-tune the environment. Notice that this AutoYast profile has included the Salt Minion software as part of the installation. Also, the service will be set to enabled so that it is running as soon as the installation is finished. We have also edited the post-installation script to point the Salt Minion to the Salt Master, which resides within SUSE Manager. This AutoYast profile has access to the SLES12 SP1 distribution and its child software channels. This is the second half of the OS installation. Additional software packages are installed and settings such as LAN, firewall, and services are configured just before the server is ready to be accessed. OS installation has completed on the server, and we can now access it. Take note of the hostname. Going back to the onboarding section of SUSE Manager, we can see that the server has automatically joined with SUSE Manager via its Salt Minion, which was installed and configured to automatically join the Salt Master. Note that we have configured this specific Salt Master on SUSE Manager to auto-accept all incoming public keys. We can now perform specific functionality on the server, like onboarding it to specific groups, installing packages, and applying updates, applying salt states or formulas or other operations. Flipping back over to the CLI, we can execute salt's test.ping command to verify that the OneView proxy and the newly configured server are both responding. We are about to use SUSE Manager to install the Docker package. Let's make sure it's not already there. We'll select Docker in this list, and now we'll run the installation. Let's check to make sure that Docker was actually installed. This concludes the demonstration of this integration, weaving together OneView, SUSE Manager, and SaltStack. In this demo, we provisioned a fully configured server from bare metal to login prompt and onboarded in SUSE Manager with a single salt command. SUSE Manager then was used to install Docker, preparing the server for container workloads.